Morning, everyone. I'm audible to you guys. Okay, so today we will start a new topic, which is graph data structure. So when I said graph, can you tell me what's in your mind? Graph, lines, okay, and what else? Other than lines, x and y axis. Okay, you are talking about our graph paper. Okay, still fine. Then you said lines, right? Any pattern on two or three axes. Okay, axis, just think about 2D. Everything is 2D for the time being. So you said lines, then there should be something, right? Lines between what? Okay, graph consists of nodes and edges in a plane. Yes, correct. So graph is a data structure which mainly consists of nodes and edges, or you can say vertices or vertex and edge. Okay, so it's just a collection of nodes that have data and are connected to other nodes with the help of an edge. Okay, so can you give any example? Any example of graph? A very common example, bar graph. Okay, those are like the for visualization. The bar graph, pie chart, those are for visualization for showing your data. Now, graph data structure, if I'm saying it consists of nodes and vertex or edges, then you can think about very common is, yeah, those are your visual representation. But this is a data structure. Data structure, you are going to store data in certain form, and that form is your graph. A very common example is your Facebook. I hope everyone is using Facebook, right? Or any social media network, even the Netflix. Okay. So what happens in Facebook? Everything in Facebook is considered as a node. So notes can be your user photos, your albums, even groups, pages, your stories, links, everything. Just any data that is stored in Facebook is a node. Okay, then every relationship in an age from one node to another. So you can just think whether you post a photo or you are joining a group or you are liking a page, etc., anything, those are the relationship between the nodes. Okay, it's like a new age is created for that relationship. Okay, so you can just think that your Facebook is a collection of nodes and ages. Okay, so your Facebook also uses a graph data structure to all your data. So if you are having a friend and next day you are adding new friends, then you are a node, then your friend is a node, you are making a connection, you are just added him as your friend, then it's a relationship. Okay, so even if you like use Spotify, you are listening to music, everything you can think as a node. Okay, and the relationship between two nodes is just think about as a data, or it's an age or an relationship. Okay, is it clear? So, in a graph data structure, a vertex will be said to be adjacent to another vertex if there is an edge connecting to each other. If there is no edge between any two nodes, then those nodes are not adjacent. It will be adjacent only if it has an edge, or you can say if it has a relationship with the other node. Okay. So very common operations are like you want to check any element in the graph or graph traversal. Graph traversal we will discuss later. Then you want to add vertex or edges. Then you want to find a path and all. Okay. So there are certain terminologies for graph. Okay. It's very important to understand these terminologies. So if I say path, so path you can say is just a sequence of nodes that are followed in order to reach some terminal nodes. Okay, okay, let me show you. Suppose I'm just drawing. Graph can be of any type. Okay, your nodes can be arranged in any ways, doesn't matter as long as it has a node or edge, then it's fine. So if I'm just saying this is node 1, 2, 3, and 4, this is a graph because it consists of so graph you can just represent as set of B and E. Okay, V is a set of vertices. So what are the vertices here? One, 2, 3, 4. Correct? And what are the edges here? Edges you can consider every edge between two nodes. So edges will be one edge from 1 to 2. Okay, one edge from 2 to 3, one edge from 3 to 4, and one edge from 4 to 1. Okay, if you want to add some names then also fine. And there's another term is cos. If I'm saying, okay, let's come to this part later. Okay, so for the time being, just simply graph is a set of or collection of vertices and edges. So vertices will be set of whatever vertices you have, then edges will be all the edges between two nodes. Okay. Okay. So next, what is path? Okay. Okay. Before path, I want to say that there are two types of graph. Okay. Two types of graph. One is undirected and one is directed. From the name itself, can you tell me what is undirected and what is directed? This graph is directed or undirected. Your undirected graph is when your edges do not point to any specific direction. Okay, it's like no specific direction. And for directed graph, there will be specific directions. So this is your undirected graph. So you can also say your undirected or undirected graph is also your bidirectional graph. Okay, this is also bidirectional. Why it's bidirectional? Why is it bidirectional? I'm saying this one is undirected, but at the same time, I'm also saying it's bidirectional. Okay, I'm drawing another graph here. So this is your directed graph. So just look at this two figure. Now you tell me why this undirected is bidirectional, because it's pointing to in two different directions. Not two not like two different directions. It is called bidirectional because you can go to either way. Okay, you can go from 1 to 2. You can again move back from 2 to 1. From this age also, you can move from 2 to 3. Again, you can move from 3 to 2. You can just move around in any direction. If a node has an age, then from that node, you can go to another node. Again, from that another node, you can again go back to that node because there is no specific direction. That's why you can just go in both ways. But in case of directed graph, there is a specific direction. Okay, I'm saying from 1 you can go to 2. But there is no age between means from 2 to 1. That means from 1 you can only go to 2, but from 2 you cannot come back to 1 again. Why? Because there is no age that is directed from 2 to 1. Okay, in this graph, one from one node 1 you can only go to node 2. From node 2 you can go to node 3. From 3 you can go to node 2 because there's two edges between 2 and 3. One is going from 2 and one is going to 2. From 4 you can go to either 3 and node 1, but you cannot go to node 2. Okay, so that's the difference. In a directed graph, you have to just maintain or follow the same path. But in case of bidirectional or unidirected, there is no specific direction. That's why you can just move in both ways. In both ways. So is it clear? Types undirected and directed. Undirected is also known as bidirectional. At this point, is it clear? Okay. So now come back to this point path. So what is path? Path means what? It's your just normal path. What means when I say path, what do you understand? Path means what? I can go from, ma'am, if direction is given means directed graph. Yes, correct. If you see an arrow in a graph, that means that graph is a directed graph. But if you don't see any direction or any pointed arrow, just normal edge, then that one will be your undirected graph. For directed graph, there will be arrows, and for undirected, just simple edges, no points. So path means what? Path means you can go from one point to another. So you can just say that a path can be defined as like sequence of nodes that are followed in order to reach some terminal nodes. So if I'm saying that A is the one is the source node and 3 is the destination node, so I can say there is a path from 1 to 2, then 2 to 3. So there is a path from 1, 2 and 3. Correct? That's the path. If there is a path from a source node, you can serve from where you want to start. Then you also have a destination. The path is just sequence of nodes connected by some edges. For here also it will be same. You want to go from 1 to 3. There is a path between 1, 2 and 3. Okay, that's the path. So next term was closed path. So can you tell me what is closed path? Closed path. What is closed path? Formation of cycle. Yes. Okay. Now tell me what is cycle. You said circle. Not circle, not necessarily. It will be a circle, but yeah, you can say cycle. Continuous loop, maybe. It's not even exactly a loop. You can say just one loop. So your close path means if the initial node is same as the terminal node. So if I say this is my initial node, this is my initial node. So after moving around the graph, I reach the same node again if initial equal to your, wait, wait, hello. Okay, Imam say close path means which starts and ends at the same point. Yes, correct. That's the correct answer. If you start from a same point and your ends also at the same point, it's initial and terminal node. Terminal node means your destination point is same, then it's a close path. Okay. Then there is another term, simple path. Simple path means if all the nodes of the graphs are distinct except your uh, means means both initial and terminal nodes are different and all the nodes are distinct, then it will be a simple path. So if I'm saying this is my initial node and this is my terminal node, then this part is a simple part. Again, if you come to this point, if I say I want to 1 from 3, this is a simple part, 1 to 2 and 2 to 3. Okay, if I am saying I want to move from 4 to 1, then there is a simple part, just normal part. Okay, and if I am say I want to move from 4 to 2, then it's again a simple part, 1 to 2. That means your starting and ending point should be different. Okay, but it just all nodes are distinct and no repetition of the nodes. Okay, then next comes your cycle. I guess, yeah. So cycle means you already know if there is a path which will not have any repeated edge or vertices except the first and the last vertex. So you can also say cycle is also like your closed path. Okay, it will also form a cycle. Next is your connected graph. Connected graph is like just normal graph, but there should not be any isolated graph. So in future you can also see some graph like uh, these are just vertices, right? So if I am saying this is a graph and there is a single isolated node, it should not be like this. That means whole graph should be connected. There should not be any isolated nodes. That is your connected graph. Okay. Then complete graph. Complete graph means in it's a graph where like every node is connected with all other nodes. Okay. So suppose this is a graph. Okay, this is an isolated graph, it should not be like this. So every node at least should have a connection to each other. If there is no connection, then it is not a complete graph. So a graph will be complete only when there will be an edge between each pair of vertices. Okay, so there's a simple formula. Suppose a complete graph contains like n into n minus 1 number of edges, where n will be number of nodes. So if I'm saying in a complete graph the number of nodes equal to n, then edge you can calculate like this. If I say there are like 3 nodes, then you just need to and find out how many edges will be there in a complete graph with the 3 nodes. Then you can just use this formula. So what will be the formula? 3 minus 1 2. Give me the answer. 3. Correct. So edges will be also 3. So you can just form a graph like this. This is a complete graph. Okay. Next comes your weighted graph. Okay. Weighted graph, I mentioned about this term earlier. Weighted graph will be a graph when I will provide some pause to the edge. Okay. If I am saying there is a cause between two uh, vertices or nodes, then it will be a directed graph. Okay. Okay. Let's see. Okay. Suppose this is your undirected graph. Now I am just saying that every edge will have a particular cost or value to the edge. Okay. then this is your weighted graph. Okay, if I'm saying I want to move from, means I'm saying I want to start from the node 1 and my destination is or terminal is 3. Can you tell me what will be the possible path from 1 to 3? This is my initial point and this is my destination. So what are the path from 1 to 3? One path is from 1 to 2, correct? From 1 to 2, then 2 to 3, correct? Then another point is just a single age between 1 to 3, correct? There's another part which goes from 1 to 4. So 1, 4 and 3, correct? 3 parts. So now can you tell me the cost of each part? Cost will be the addition of all the cost, means all the values in your way. So for this part, the cost will be 1 plus 2, 3. This is your cost to follow this part. Then from 1 to 3, the cost is 1. Then again for this part, the cost will be 3 plus 2, 5. Okay. So which part is having less cost? This one, right? This one is the lowest cost. So in future, okay, Deepashi didn't understand. Okay. This is your weighted graph. Okay. Weighted graph means what? Every age will have a particular cost or a value. Okay, it will have a value or a cost. Okay, now if you want to move from one node to another node, there will be a different path. Okay, so just in simple way, just learn that every age will have a particular cost. But in future means in there are various algorithms we want to optimize our traveling, right? Okay, just think about your Google map. When you search your when you do like searching in a Google map, you just give your pickup point, right? Then you give the destination point. So from pickup point to your destination point, obviously there will be like more than 2 3 paths, correct? Cluster bus. It will. Ah, emang চাব লাগিব মই চোৱা নাই হা মই চাব লাগিব হাৰ্ড কপিটো আছেতো আমি প্ৰিণ্ট কৰিব লাগিব অঁ সহায় কৰি দিম অঁ প্ৰিণ্ট কৰিব দিয়ে এইটো চাই ল'ম তাৰপিছত মিটিঙত যাম মই যাম বাৰু Okay, so when you book a cab, obviously you use a Google Map, right? So there you write a pickup point, then you write the destination point. So from your pickup point to destination point, there will be lots of different paths, correct? Now in those alternate paths, they always show you the shortest path, right? So how they calculate that shortest path in a map? Just give me that answer. In a Google map, how they show us the shortest path from our source to the destination. Shortest distance, yes, correct. It's the distance, is the distance from one point to another. So in case of Google Note, the cost is the distance. So whatever path will have the least distance, the shortest distance Uber just follow that route, correct? Or it also just give us less traffic? No, no, it's not the traffic. Mainly they show the distance. Traffic will come later. It's like external thing, but mainly it just shows the distance. If I'm saying from here to Narangi, there is one path and there is another path. So obviously you will take the shortcut, right? Because that path will give you the shortest path. It will so that you can just travel in less time. Okay. So they even the Google Map also use the same data structure, graph data structure. So just that whenever they put some relationship or the ages, they put cost as a distance. Your cost can be anything based on your application. Just remember here, cost will be certain values. Okay, a value is given to your weight. Certain weight is given to the age. Okay, in this in previous two times, there is no cost. There is no cost from here to here. No cost assigned to a particular age. So these are not weighted graph. Okay. So a graph will be weighted only when every age will have a particular weight or a cost. Okay. In future, we always try to find there's another algorithm which you will find in a mm design and analysis of algorithm class, which is a traveling salesman problem. Okay, so in a traveling salesman problem, we always try to find out, means a salesman will be there and he wants to just travel to different cities, and he needs to find out the shortest minimum path within which he can just complete most of the cities. Okay, so the age have the certain costs which we have to add. Yes, correct. So here in case of weighted graph, there will be a cost or weight assigned to every age. So if I'm saying you need to go from one point to another, you have to add up those costs. Okay, here I'm saying initial is 1 and the terminal is 3. So I will check what are the paths from 1 to 3. Since it's a undirected graph, there are 3 paths from 1 to 3. Correct? So for every path, I will see the cost. How will I calculate the total cost? Total cost will be the summation of every cost for each age between different pairs. From 1 to 3, if I follow this path, there is a node 2. And if I follow this path, there is a node 4. That means what? There will be an age from 1 to 4. And similarly, there will be an age from 4 to 3. So you have to just add up those cost or weight, then you can calculate the total cost. Okay, if I'm like asking you to find the minimum cost path or minimum weighted path, then you have to calculate and see which one will take the lowest cost. Okay, this is a very important concept and which are used in various different ways, like Google Map is one of the very example of weighted graph. Okay, we always try to find the shortest or path so that we can travel from one point to another in the shortest time or minimum time, or I can say optimal time. Is this one clear? Directed graph, sorry, weighted graph. Okay, can you tell me what is a tree now? We can say tree is also a graph, right? And tree consists of nodes. So tree is also a type of graph, but it's a undirected graph. In a tree, there is it's also a form of graph. just that there is no cycles, there is no loops, but this is a undirected graph. We can just move in any direction. Okay, and tree never contains any cycle or a self loop. However, in case of graph, it can have cycles and all. Okay. In even in graph also we have another term spanning tree. I'll explain about it later. Okay. Next is digraph. Can you tell me what is digraph? It's the same. Digraph is your directed graph. Directed graph is also known as your digraph. Loop is just same, like an edge that is just associated with the same starting and the endpoints. Okay, adjacent nodes means if there is an edge from one to another node, those will be your adjacent nodes. And there's degree of node. Degree of node, can you guess what will be the degree of node? Degree of node. So for node 1, 2, 3, 4, all are adjacent nodes. Why adjacent nodes? Because there is an edge from 1 to 2, 1 to 3, and 1 to 4. Okay, and in this graph, from 1, 2 and 4 is the adjacent graph. Why? Because there is a edge from 1 to 2 and 1 to 4, but there is no edge from 1 to 3. Therefore, for 1, adjacent nodes are 2 and 4. Now, if I'm saying degree of node, that means it will specify the number of edges that are connected with that node. So for node 1, here degree will be 2, because from 1 there is 2 edges that starts from 1. Correct? That's the degree. Now in this graph, the degree of 1 will be 3. Why? There are 3 edges connected to node 1. So here degree will be 3 for node 1, because there are 1, 2 and 3 edges connected to node 1. Is this clear? What is degree of node? That is for a graph. Okay, or I can say complete graph. The degree should be at least 1. Okay, there should be at least one edge connected to the node, to a particular node. Then it will be a complete graph or just graph. If I say degree equal to 0, what will that mean? Degree equal to 0. Degree equal to 0 for node. Degree always come in terms of nodes, okay? No graph form. There will be different graph, right? Okay. Suppose this is also a graph now, correct? There are 1, 2, 3, 4 nodes and 3 edges. This is also a graph, but in this case 2 is your isolated graph, isolated node. So obviously this is not a complete graph, correct? This is not a complete graph, but it is a graph. There are 4 nodes and 3 edges, and one node is isolated node, and for that isolated node your degree is 0 because no edges are connected to this node. So this is still a graph with four nodes, three edges, but this is not your complete graph because there is isolated node. I can say, or you can say connected. Okay. For connected graph also, it's mandatory. There should not be any isolated nodes. Okay, is this clear till now? So in next class, we will see the representation of graph. Till now clear? The basics of graph data structure. All you said like bar graph, pie, those are graph, but those are for only visual representation. Now here you are studying graph as a data structure where you store the data or everything in a graph is a node and the connection between node or among nodes are your edges. So Facebook is very common example, then Netflix, Amazon, everything you can just think about as a graph data structure. Even in Amazon, you are a particular node, then all other items in the store are again nodes. If you want to buy something, then there are a relationship or an edge created between the item you want to buy and you. Okay, same in case of Netflix also. If you and other friend like sharing the account, then whatever he will see, whatever he will watch, Netflix will recommend the same thing for you as well. Very common example is your Facebook. Everything is known and all the relationship, video, music, song, pages like, friends, everything is just a new connection or age. And the Google Map as well. Okay. So I stop sharing. Take 10 minutes. I take attendance. Okay. Thank you. I'm ending the class here. See you tomorrow. Thank you.